Hello, how you doing? Happy Saturday. Hope you're doing well. Saturday where I am, but happy whatever day of the week it is wherever you are. This is rapidly turning into a bit of a catchphrase. I'm starting to feel a bit like Roy Walker, say what you see. If you're in the UK, you might get that. If you're not, you may not get that, but never mind. So what I thought I'd do today is I thought we'd give a demonstration of how things are rapidly changing. So we gave a demonstration earlier in the week of MCP, Model Context Protocol, which is becoming basically the RESTful API of AI. So that gives you a capability for different disconnected toolings to be able to connect them together and augment them with new capabilities, either from someone else or from yourself, or connected to your own agentic network to be able to do things to basically seamlessly interact and allow the whole network to more seamlessly use capabilities that are not native to itself. And also, most importantly, Microsoft announced that MCP is going to go into Windows. So this gives me the thing that I literally only said it last week. I would love AI to be a first-class citizen in the operating system, to give a whole set of capabilities, and having MCP in there allows it to do it. So someone must have been listening, or I must have seen the future. I'm not too sure. One of those two, delete is applicable. So what I thought I'd do today is I thought I'd show you what happens when you've got a capable orchestrated agentic network and a cloud service produces a capability that you might want to leverage, how you can basically augment them to give them superpowers that they neither natively have, or one is better than the other, to basically magnify the capabilities that they have, to be able to do that very quickly with almost no code, to be able to leverage that. And as you'll see from the very little code that we add, we've added it in a demonstration console app for these purposes. But if we have an MCP server that we stick behind a port, we run as a service, then we can allow any of our software stack to be able to use these capabilities with almost no code. So we're moving from the era of, and funnily enough, AI IDEs let you write code at a faster and faster pace than ever before. But actually, the secret of what to do with AI is to write less code and to use the AI capabilities to remove that necessity to write code. More code is not better. The more code you've got, the more you've got to maintain. With AI IDEs, the more entropy you get, and it'll be harder for the AI to maintain, it'll be harder for the humans to maintain. So really, we're moving to an era where we're basically trying not to write code as much as possible. Sounds a bit crazy as a developer, but that means you can be more productive. You can have more capable capabilities at a much faster pace. The productivity is increased, and AI is all about not getting rid of people, not making people redundant. We don't want to do that. It's actually giving them better capabilities, businesses a scope to move at a much faster pace than they would do historically, to produce more capable applications. And the differentiator between businesses is going to be how capable is your agentic network, and how much more capable is it than what's available to everybody else, and how fast can you do it faster than everyone else. And if you can do it faster than everyone else, you can add newer capabilities at a faster pace than anyone else, and eventually it becomes quite difficult for people to catch up. But what you do need to do is you do need to keep an eye on what's happening in the space. So when a capability comes out that may be either financially better for you to leverage it, or maybe something that you haven't been able to do before, then you want to be able to quickly pivot to leverage it, because next month it'll be out of date. So you need to move fast in the era of AI. So I've been around a bit, and this is definitely the most interesting time in technology I've seen for a long time, and the sort of obsession with code in terms of writing the code, it's more about writing the right code. So what I thought I'd do is I'd give a quick demonstration. So I've been having a little look at the Azure Document Intelligence API, AI API, which is really focused on, it's a set of models that are basically trained on different types of documents. So invoices, receipts, various types of identification documents. And it's been trained on millions of these to be very good at extracting information from these types of documents. So we've had capabilities for a while in things like AWS Textract is a good example. I know people have used that, where you can extract the text from a document, and then you can then use an LLM to be able to identify what the document type is. That's a relatively easy task if you have a sufficient volume of information in a document, and then you can use it to extract text. And I've shown demonstrations of this probably a long time ago now, last year sometime. When we did this, we used a generalized model to be able to do this. So the advantage of obviously using something like the Azure AI Document Intelligence capability is the fact that individual models are specially trained on particular types of documents. Now, What it does rely on is it relies on you knowing the type of document to start with. At the moment, it doesn't support robustly identifying the document itself. It relies on you telling it the type of document, basically, to load the right type of model. Now, we already have this capability to do this in our Agentic network. So what I thought I'd show is how can we magnify the capabilities of both of these by connecting them together. So the Azure AI Document Intelligence service has a C# SDK. Brilliant. So we can plug that into our orchestrated C# network. Our network is exposed in a way that we can consume it in different applications with very little code. So I thought I'd give you a little idea of what that is. So let's just have a quick look at what I'm talking about in terms of the Azure capabilities. So if you go into their sort of documentation for this, you can see each of these is basically a different model. So they've got a model ID and it has capabilities and trained on certain types of documents and is very good at extracting certain types of metadata from those documents. So over time, I suspect what they're going to do, they'll add more document types. They'll also increase the amount of metadata it exposes to you over time as it's more trained to basically extract more and more metadata. So these are only going to get better over time. And obviously, because it's a type of model that's trained on this particular thing, it helps with keeping the costs down because it's not exposed with lots of other capabilities that it needs to have to be able to do things. So that's kind of where you have this sort of expert model versions of AI models now, a mixture of experts where they will identify the kind of question they've got, and rather than having the whole model in memory on an active task, they'll focus on a particular segment of the memory space in terms of the model to basically keep down the processing requirements that are required to be able to service inference requests. So that's kind of what we've got. And if we look at the pricing of this here, so have a little look here, you can see it's fairly reasonable in terms of if you were making pure model requests, you probably won't be that much cheaper per se. It will be cheaper, but your document classification will probably be reasonable. Your metadata extraction, and even though I've done it, is less robust. And you're also kind of getting a dual reflection capability here. So what's really happening is not only are you having a model going away and trying to identify the document, and to actually identify it, we actually use this SDK to be able to use they've got a pre-built layout which is just focused on extracting generalized text. We use that to feed to the LLM model, which is focused on identifying the document types of a known set of document types, and then we use basically a capability to be able to load the right type of model for our particular document by having basically a mapper between what we identify as and what they have a model for, and then to be able to extract the known metadata that the model is currently well trained on extracting. So that's kind of what we're going to do. But what I really want to show is how very little data this has taken. So this has taken me probably about 30 minutes. Wasn't even focusing on it. Went down, put the washing machine on, came back, did a few more lines. So this is kind of these Lego-like capabilities of AI, what it's all about. MCP is going to be a revolution. It is the RESTful API of AI. And it allows you this capability to connect different sets of AI toolings on a machine to be able to do various bits and bobs. I don't know, maybe someone was listening last week when I was talking about MCP. I was talking about what I really want is an AI-friendly operating system. And what Microsoft also announced in MS Build 2025 is that they're going to add MCP to the core operating system. So the thing that I say I would love is happening, and this is going to give the capability to be able to more tightly integrate external capabilities for doing AI, which I use a lot of, but sometimes it's hard work to be able to connect them together. I do it, but it's hard work, which should be a relatively simple task if we can expose them in this very friendly way that different toolings, and the operating system is a set of tooling, can be able to connect them together. So once you've exposed this capability, say as an MCP server, you've got other tooling, so you're using an IDE, for example, extension, and a cursor, windsurf, client, then they're all supporting MCP now. So you can actually add in new capabilities for these to be able to interact with these capabilities. And you can have different types of MCP servers for things that you want exposed to AI IDEs, things that you want exposed to your own internal applications, and maybe things that you want exposed to external applications. So it really is the RESTful API of AI, and you're going to be hearing a lot about it, and it's a very powerful capability. So I cannot wait for it to be in the operating system. So this has been a great week just for that sole reason. So let's have a look at some code now. Give me a second and I'll get it up. So basically, really, all I've got is a couple of functional classes here. So I've got one that uses Azure's API for document intelligence and form recognition. and I've created a very simple little interface that exposes some core capabilities. So I have one, so basically we have a constructor that basically gets the connection requirements, essentially the pseudo connection string, creates an admin client which allows me to basically demonstrate the list of models that are available, and then we have an analysis client which then allows us to go away and look at the document. So we have a return model capabilities that will just list in the particular region I'm connected to what models are available to me. We then have an identify document type capability, and that actually uses the document analyzer, the pre-built layout, to basically extract the text for me. I can do it myself. I've got capabilities to extract from various documents, but it's just another thing I don't have to worry about. It does it for me. And then essentially I use a single line call to an agentic network broker, which has a capability to identify a document, which can take that and it will robustly identify what the document type is and return it. Following on from that, we then have the capability to introspect the document. So what we do is we use that initial analysis of the document type to basically tell it what the document type is, which then allows the SDK to load the right kind of model. It has a mapper between what I call it, what they call it, and then it goes away and extracts the current known metadata. So over time, there's going to be more models for different types of documents. And the advantage of having models for different types of documents is they're going to be smaller models, which keeps the cost down. So I suspect that's one of the reasons they've done it. You could have a behemoth model that does all document types. It'll probably be a lot larger and therefore more expensive. Or you can use a smaller model and save money over time by identifying it and then doing the difficult thing, which is extracting the information. So that kind of makes a lot of sense of how they've engineered this, and I'm assuming that's probably why they've done it. So what we then do is we then extract the known metadata that's come out of the document, and this, again, over time, they'll continue training these models, retrain these models, add more data, and then they'll expose more and more metadata to expose more and more things in the types of documents you see that are in the wild to be able to give you more and more stuff for free. So these will only get better over time. So that's essentially the document analyzer. So we've got our own agentic network. So essentially a very simple broker here where I expose a capability essentially to instantiate the network, and it's only using one particular model capability, and then it's basically just allowing it to identify the document. So this model is purely focused on identifying document types. That is then used to map back to what Azure call it, and then we use the capabilities of the Azure AI to be able to do it. So let's have a little looky at what we can do with this then. So let's fire up the beast. So we've got a very simple console application behind it, which just allows me to run a few commands just for demonstration purposes. So this could be hosted inside an API. It could be hosted, and these two classes could be hosted behind an MCP server and exposes an MCP capability, and then straight away anything on your network that can see that MCP server has that capability to basically use this tooling to do this thing, which you might not natively be able to do. And that's not a thing models generally are natively exposed capable of doing. But if you've got a chatbot, for example, you might want it to be able to download an invoice, analyze an invoice, look at what somebody send a document they've received, extract the information, look at it, identify context relevant to the information it's seeing. So obviously it's a capability that is probably more focused on ingestion of documents, but you could expose it via MCP, and that's the main thing. So let's fire up this thing now and we'll give it a go. I have to minimize that so you can see the console window. Give me a second. Here's the console. So the first thing we'll do is we will list the set of models in the region that we're connecting to, and these models may be different depending on which region you're connecting into. I'm using UK at the moment, which probably has less models than other regions just because it generally is a little bit behind other regions. So let's have a look at what models are available. And there we go. So here's our set of models that this region can interpret, and you see from the document I showed you earlier there are several dozen models there. So obviously depending on which region you use will expose which type of documents you can sort of interact with. So there we've got the list of models. So we'll take a document and we'll take the sample document, one of the sample documents that Microsoft supply as part of their sort of background readme of how to use this service. So it's basically an invoice. So what we'll do first is we'll fire up our own agentic network, which will fire up the Azure Document AI capability to be able to extract the text, and then it will identify what the document is. So let's do that now. So that will essentially upload the document, the model will run to extract generalized text, and then our model, our LLM, will run after that, our local agentic network, to be able to identify the document type. So off we go. So the analysis has started. So it'll take a few seconds and then it'll come back with a response. So there's some thoughts there about what the model thought about the document, which isn't relevant to what we're doing, but that comes back anyway. And we've suppressed some of the JSON capabilities of this because we're not using them, because we're using a more specialized model to do this. And you can see that the model has identified it correctly as an invoice. Not only has it identified it correctly as an invoice, it knows what types of models are available in the region we've got and how to map the models across between the two, so that it will then be able to fire up the right model if we choose to introspect the particular document, which is something that we'll do now. So let's introspect it. Oops. So now we're introspecting the documents. Now we've actually loaded a particular model that's focused on analysing invoices. And then you can see basically here we've got the known set of fields that this can extract. So things like addresses, invoice IDs, purchase order numbers, customer name, customer ID, invoice totals, previous unpaid balance, all the common fields that it's seen in what it's been trained on. And over time, these fields will become more and more sort of enriched with more information. So they'll extract more and more information from these type of documents in a robust manner. So the idea is you only extract information that's really robust, that you know is going to be accurate 99.9% of the time. Or, well, actually, they give you a confidence level, so it's not always that high. So we're ranging from 0.95 to 0.97. So they give you a confidence figure that is related to the information that's extracted. And also, if you're using, we've used a different model to identify the document type. If it was the wrong document type, this model would then extract very little information because it would recognize it's the wrong kind of document type. And also, the model I've previously shown you actually does have capabilities to extract this kind of data on its own using a generalized model. So what you can do is you could actually then, you could use reflection to improve the confidence levels by having the two compare each other's results. And if there's a deviation significantly over some key information you're interested in, then at that point you would say probably better not to classify that particular document. So I thought what I'd show you there is under half an hour, a few dozen lines of code, an agentic network that exposes an SDK that I can consume. I could stick that behind an MCP server. We're using the Azure SDK, and under half an hour we've added this capability to connect these two different systems together. And if we wanted to, we could create an MCP server to do it and then expose it to other AIs in our network. So this can be any capability you can think of. But what we're doing is we're taking one thing which is good at something, another thing which is missing one thing that we want, combining them together, and also not only getting a better capability than we had before, but we're also giving a capability to reflect, because we've got two independent sources of truth that can basically cross-correlate with each other if we so chose, to be able to then increase the confidence that the information that's coming out is very high quality. So that's really all I wanted to show today. I just wanted to show that basically it's all about connectivity. It's all about Lego building blocks of AI, which I've said all along, and I've built my own Lego blocks going along. And now, thankfully, MCP allows me to be able to do a bit less work to do what I want to do, to be able to connect these things together. So that's really all I wanted to say today. I just want to wish you a great day, rest of your day. Hope you have a wonderful day. Look after yourself, take care, and I'll speak to you soon. Bye-bye for now. Bye.